Welcome back to this Ansys simulation software tutorial series. This video is going to cover Ansys Workbench. The videos previous in this tutorial series have covered the theory behind FEA and the background knowledge behind Ansys, as well as how to get it set up. So in this video, we're going to move on to actually learning the simulation software. We're going to talk about Ansys Workbench, which is where all of the other apps are launched from, and in the next video we're going to launch Mechanical and actually simulate something. So the first thing you're going to do is type in your search bar Workbench. This is Ansys Workbench, and this is where all of the other Ansys applications will be launched from. It does not start with Ansys, it starts with Workbench, so that's worth noting when you need to open this up in the future. Go ahead and open that up. You'll get this Ansys Opener app, which is going to take a minute to load up, but I'm going to skip ahead. All right, Ansys is now open, so you can full screen that, and we will take a look at the interface. First up, we have the ribbon here at the top with a surprisingly small number of buttons, which are all concentrated on the left. We have the toolbox across the left side of the screen, which is where you'll get all of your simulation options from, like static structural, or maybe something like hydrodynamics or electricity. You have the project schematic, which is what we're going to move these into and link them all together before we open Ansys Mechanical. And then you have the status bar across the bottom, which shows if you have HPC connected and is where you access any messages that Ansys will be giving you. You won't be using HPC, odds are, but maybe if you're on campus, you'll need to access that. This also shows you if it's ready or if it's currently doing something, like if it's opening up Ansys Mechanical, because that takes a minute as well. So let's discuss the ribbon at the top. There are several tabs here, but the only ones that you're going to need to know are File, which is where you can make a new project, open, save as, and that's about all you need there. View, if you mess with this view and everything breaks, then you can go to View and click Reset Workspace or Reset Window Layout. And this will also show up a few new windows under Workbench. So Toolbox Customization window, that pops up. You can close that. Or Messages, that's another way of opening it instead of clicking this button. Tools you don't need. Units is useful because you can change your units between SI, metric, and US customary. OptiSlang you do not need. Extensions you don't need either. Jobs is for HPC, and odds are you don't have HPC. We won't be using that in this tutorial either. And of course there's help, so that's useful if you need something. And also context help is F1 as usual on computers. So if you're clicking something specifically and you need help with that specifically, you can select it and then click F1, and that should pull up some help for you if you need some help with that. So next we have these buttons down here. This with what looks like a little globe, it's kind of hard to say what it is, would be Ansys Minerva save and load. You don't need that. You're probably not connected to Ansys Minerva unless you're working for a company. I think that's Ansys's cloud storage service, but we won't be using that. We will be using these icons down here, which are the new load, save, and save as. You know what these buttons do, but just in case, I'm going to go over them again. This is how you create a new project. If you have a project already saved and you want to load it, this is how you load it. I probably should show you what exactly you need to click to open it. The thing you're going to click is the one with this little icon. .wbpj, Workbench project. This is the one that you're going to open if you want to open a project. The rest will need to be near it, and you shouldn't move those around, but that's not what you're going to open. Save, if you have a project with stuff going on here and you click save, it'll just save it. If it's the first time you saved it, then it'll let you pick where you want it to save it and what you want it to be called. which is just what the Save As button does. The Save As button will let you pick where you want it stored and what you want it to be called. If you have a project going and you've already saved it once and you click Save, then it'll just update that location with the same name. But if you have a project going on and you've saved it before, but you want to make another copy of it, you can click Save As again, and that will let you click a new location and a new name. So those are pretty straightforward, and you probably know what those already do. So next is the toolbox. This is where we're going to get all of our simulation systems or analysis systems from. You can minimize and expand these. The only ones you're going to need for this tutorial is just the top one, but these others exist, although I've never personally used them. So this is where you're going to get the static structural, which is what connects to Ansys mechanical, which we'll be using for this video. But before we start moving towards doing that, I want to explain how the windows here work, because I didn't know that until I was preparing for this tutorial, and that's kind of useful to know. It's not just static like this. This is not just the way it always is. Every little window here is customizable, and you can move it around, and you can open them and close them via these three little buttons at the top here. You can minimize the window. Minimized windows will hide down here with little tabs. Let's open another one, Toolbox Customization, and minimize that as well. You can see they're both hiding down here. If you click it, it should pop back up again, and you can minimize it. So if you float it, that's the other option here. It's also this pin icon right here. Then now it can move around just like it's a window on a desktop. And now the float button has changed to dock, which is also this button, which will put it back in its place. So if you float it, now maximize becomes an option. That makes it fill up your entire window, and restore will put it back to its normal size. You cannot drag it into place over here. You have to click the dock button. You can also close things with the X button. So this, for example, we don't need. You can close that. You can also close this, and you can do everything here as normal, and you can float this and move it around, and you can close it. And now at this point, there's just nothing down here. So how are you going to keep working on your project? Well, that is the view button, where you can click reset workspace, and that'll put everything back to normal. So if you close something, don't worry about it. This button up here is your friend, and it'll restore everything for you. So that's how it works in Workbench. It's a little bit different under mechanical, but the idea is the same, that Ansys gives you these little windows, and you can move them around, and you can kind of customize it how you like, and you can always reset it if you need to. So now let's discuss how to actually set up a system. Static structural is the one for Ansys mechanical. What we want to do is want to take this from out of our box of options, and we want to put it into the actual project schematic. There are two ways. You can double left click, and that will put it here, or you can click and drag it. Now you'll notice that if you right click and delete these two, that the first time I wanted to drag it, it showed me one option, this one right here. So I can drag him up there. But after that, it shows me a bunch of options. I can move it wherever I want. And you can keep sort of playing building blocks with this. And it's not particularly important that you need to know how to use this, because you're just going to be making projects with one analysis system at a time, which would be Ansys Mechanical if you're following these tutorials. And you may get into some more complex ones later, but for now, this is just what we're going to be doing. So just drag this one guy up here, and that's where he can stay. So the first thing you're going to want to do is rename this. This is not important. As far as I'm aware, this isn't saved anywhere else, maybe somewhere under mechanical, but it's nice to give it a name, so we'll just call this Tutorial System 1. And that is now its name, and that's just where that stays. So that doesn't really do anything, but now let's discuss how we can interact with this. Left clicking doesn't do anything. You can click these and that's fun. It just selects them. You can left click this drop down and that'll pull things up. The same as if you right click. Okay, no, I was wrong. Let's see. You can left click this right here, which will do the same thing as if you right click. It will let you update it, duplicate it, export it, delete it, and rename it, and even add yourself a nice little note. If you double click any of these, then it's going to open them. So don't double click anything yet because that might pull up mechanical and we're not ready for that yet. So we're going to start our project by saving it. It's important to save your project now that you've got it started. And I will note it's best not to have this backed up to any cloud services when you save it, because then it might have conflicting file permissions, and Ansys has gotten on me a couple times saying your project may be potentially corrupted. So if you can save this somewhere that's not cloud saved, then that could be advantageous for you. I'm going to save this here. You can save it wherever you want to. So let's just create ourselves a new folder. I should bring up saving conventions. I have not been made aware of any official conventions, but here's how I like to do it. I like to create a new folder, and I like to give it the name that I'm giving to the project. So let's call this tutorial system, and then we'll label this holding folder, and that's what it'll be called. And then you can go into this and just name this tutorial system. The name that you gave to this folder does not directly affect this. I just always give them the same name to avoid confusing myself. And the reason that I put this in its own folder with no other projects in that folder is that I know this is going to create that .wbpj file that I can open, as well as two other files, and I don't want those to get confused with other projects that I have, so I give it its own unique folder. Then you can click Save. And now the thing should be saved, and if you click this, it'll just update it and it won't bring up that dialog again. And so let's just take a look. See, now it has all of these saved in here, and we don't want that to get confused with others, so we have it in its own unique folder. All right, now that that is done, we're going to move on to setting up our system. We're going to do this in order: engineering data, then geometry, model, setup, solution, and results. So and I should note that this does not actually do anything. It's just there to tell you what kind of a system it is. If you double click it, it doesn't do anything. So double left click engineering data, and that will pull this window up. If you'll look, you'll see that there are now two tabs. Where there was previously just project, there's now engineering data. When you double click engineering data, that's going to pull this dialog up right here. And that's kind of unique to engineering data. The rest of these are going to pull it up in a separate software altogether. So go to the engineering data tab here. It's a little confusing what engineering data means, but all that it means is what materials are you using and what are those materials' properties. So there are four little windows under engineering data. There's outline, properties, table, and chart. But we do not need table and we do not need chart, so you can go ahead and close those. If you need to get them back, you can click Reset Workspace, but we're going to have those closed. Outline is going to show all the materials that are used in our project, and properties is going to pull up the table of properties of whatever material we have selected. Let's go over what each row in outline does. So this is just the labels. This is more labels. You can sort all your materials ascending or descending or some other way using this. This is the color row. This little Xbox icon is the suppression row. This is where you got the material from, and this is the description, which is just for you to put there so that you can, have any notes that you need or tell someone where you got that if you made it custom. You can left click this and that will pull it up in properties. You can double left click to rename it. You can right click to pull up some options like view sources, delete, duplicate, or engineering data sources, or expand or collapse. You can left click this to choose a color, and that's kind of useful for differentiating your materials in your project. You can suppress or unsuppress this. If you suppress it, what that means is Ansys is going to pretend like it's not in the project, even though it's still there for you to quickly unsuppress and basically add back to the project if you need it. Source is not that important. You can left click, you can right click, and then for description, you can double left click to edit or right click as well. Let's take a look now at the properties of this steel, this structural steel. So material field variables, I'm not really sure what this line means. It says table, and I'm not really sure what that's used for, so you can ignore that. But we also have density and isotropic secant coefficient of thermal expansion, isotropic elasticity, strain life properties, tensile yield strength, compressive yield strength, etc., etc., with the property being named here and the value of that property being named here and the units for that value being named over here. So its density is 7,850 kilograms per cubic meter. You can double left click this field to edit the value in it, and you can click the drop down on this field to change the unit. If you change the unit, it's not only going to change the unit, it's also going to convert the value automatically for you. So if you have it in, let's say, tons per cubic millimeter or whatever that means, and you just had the value in that because you got it from some weird source, and then you put the value in and you wanted to convert it to kilograms per cubic meter, you could easily do that. But that's also a note that if you're putting in a value, you should select the unit before you put in the value, because if you put in the value and then change the unit from the default to whatever you had, then it's going to convert your value and you'll either get it wrong or you'll have to enter it a second time, and that's just kind of annoying. There is also a suppression row down here, so you can suppress this property. And there is also a parameterize or turn me into a parameter button that will let you create parameters for each of these values, which means that you'll be able to, well, I'll just show you. If you look at project right now, this is what you see. If you turn this into a parameter and go back to project, now there's a parameter set, and that's created a new row down here, and this parameter set is the input for row 8. You can double left click this, and now you can input the density from here. And this is great because under mechanical, you can make other things into parameters, like how much force are we going to apply, or what's the direction of the force, and that will let you edit all of that from here if you're going to be changing that for a bunch of different options under the same basic simulation. So, but we don't need this right now, so we're going to unparameterize this. It's also worth noting that some properties are drop-downs. So isotropic elasticity in particular is a drop-down. You can see it jumps from 6 to 12 here, and that indicates that 6, 7, 8, 9, 10, 11, 12 are there. Everything is stored under here. Isotropic elasticity is also interesting because they have this derive from button, which lets you tell it, I have these two values and I want you to find the other two for me, and it forces you to have the other two. So you can put the two in here with their units and then it'll find the rest for you. So that's how the properties works. You can also add values to this set of values here. Let's say we wanted to add puck constants. You can left click and drag this over here, and this will pull up another drop down for you, and you can edit this. You can also right-click to delete properties if you didn't like the properties that you had. And you cannot Control Z to go back, so only do that carefully. Okay, so how do we get more materials? Are we stuck with structural steel? Well, no, we are not. And the way to get more of these is to either left-click Engineering Data Sources, which pulls up this new window. See, here's Outline and Properties, or here's Engineering Data Sources, which can be closed by clicking this again, or you can right-click and click Engineering Data Sources, and it will do the same thing. Each of these bars can be grabbed and dragged, and it's also worth noting that you can drag this bar sideways as well. So let's open Engineering Data Sources. This is where you're going to find sets of materials. So explosive materials, general, nonlinear, composites, general. Let's go for general. So left click this, and then we're going to drag this up. Outline has now, it no longer shows which materials are being used in our project, but which materials are listed under general materials. Here's air. I don't know why you would need air. Aluminum alloy, concrete, copper alloy. Actually, you might need air if you were doing computational fluid dynamics, but we're not doing that right now. So let's go to stainless steel, structural steel, and titanium alloy. We'll be using these three. You see this little book icon? That indicates that it is used in this project. If we want our one of these to be used in the project, we click the plus icon and look for the book icon. So there we just added stainless steel, and if you close Engineering Data Sources, you'll see that that's now here too. Stainless steel and structural steel. Reopen Engineering Data Sources, make sure General Materials is selected, and go to Titanium Alloy. We will also add this one to our project. Then left-click Engineering Data Sources, and Outline switches back to showing what is in our project. Let's give each of these a different color. We're going to make this one a nice red. We're going to make this one a nice blue. And we'll make the other one a nice green. We're not going to suppress any of these. Actually, let's make this green maybe a little bit more neon so it's differentiated. There we go. And this, so we're not going to suppress anything, and we can leave the rest as it is. If you click these, you'll see that their properties are all a little bit different. That's because they're different materials. So that's how you get more materials, but that's obviously a limited number. What if you have a different kind of material that's not listed under engineering data sources? Well, the way to do that would be to make a custom material. I've done this before when I added a custom carbon fiber material, which we had personally tested for Rocketry to get the materials data so we can know how it would behave for our simulation. And that's just right here. Clicked here to add a new material. So if you left click, you can give it a name. We'll just call it, how about tritanium? That's a make-believe substance that doesn't exist. Now it's got this little question mark because we don't have it enough properties. So let's make this one yellow, a nice bright yellow. And then we're going to add it some properties. Make sure that the tritanium is selected and not the rest of these. And we're going to add some material properties, and then we're going to add those properties. There's only a few that you're going to need, probably if you're just looking up a material for material values online. You may need a couple of others. It's worth looking through this if you need them, or if you've been given a specific one and you need these specific properties, put those in. But generally speaking, under physical properties, density, close that. And then under linear elastic, isotropic or orthotropic, we're going to go for isotropic. Isotropic means it's the same it's the same stress strain no matter whether you're applying it in this dimension or this dimension or this dimension. Orthotropic means it can vary by dimension, and anisotropic, I think, means that it can start to change depending on how much you compress it. Honestly, I'm not that sure. We're going to go for isotropic. Then under strength, tensile yield strength, compressive strength, tensile ultimate strength, and compressive ultimate strength. Now, it doesn't matter where you drag it. Let's just go ahead and delete this. Tensile ultimate strength, I could drag it here and it'll still put it at the bottom. Or tensile ultimate strength, I can do what I did before and drag it at the top. It'll still put it at the bottom. So don't worry about where you're dragging it. And then there's nothing under the rest of these that you're probably going to need. So we could just create some values here. Let's make this derived from Young's modulus and Poisson's ratio. We'll give this gigapascals and then 50, and Poisson's ratio will be 0.8. We'll make density, how about 100 kilograms per cubic meter. Tensile yield strength will be 60. This will be 65. And then this can be 75, and this can be 85. There, now we've just made up a material called tritanium. Now, is that particularly useful? No, but it's just to show you that this is how that you can add materials if you need to add custom materials to your project. Once you are done adding your custom materials, you can go back to project, and you should see a little check mark here. We don't see a check mark because we've got structural steel with a question mark because we deleted and added some things. So let's just right click, delete, back to project. Now we have our check mark. So that means that this tab is done and we can move on to the next one. The next one is geometry, which is not to be confused with model. Geometry is going to be the shape of the object that you're using. And that sounds a lot like model, but it's actually different, so don't get them confused. Geometry, there are a couple of ways to get the geometry for your project. If you already have the geometry, you're going to right-click and then go to Import Geometry. Then click Browse, and you can browse through your files to find the geometry you want. Let's say nosecone.xt. Open that, and you'll get a little check mark with a little P, meaning you imported it. I'm not sure why it's a P, though. It's important to note that Ansys likes parasolid files best, so if you can give it a parasolid file, that would be great. And it'll also accept step files, but those are not as great, and I'm not sure what it does with any of the other file types because I haven't tried those. I would recommend parasolid. If you have a step file, then you can always import it into whatever CAD software you have and then export it as a parasolid. There's also another way to get geometry, and that would be just straight up creating the geometry using Ansys's CAD software Discovery. You could use a different CAD software, but this is also an option. If you right click, there are 3 Ansys CAD softwares. Design Modeler, which is really old and looks really old and probably is not that great for modeling, which is why I haven't used it very much. Space Claim, which is a little different. I think that's more for editing geometries to make them fit better with the simulation, but I haven't used that one much either. And finally, Discovery. As I said, I don't have a ton of experience with Discovery. I don't have much, but it's worth knowing about. So if you left click, we're actually, for this project, we're going to create our own geometry in Discovery just to give you a little bit of experience with it. And that'll let us create a simple geometry that we can use for the project. Look down here in the status bar to see it is starting Discovery. That's what this little icon is for. Red means it's doing something, so we're going to have to wait before we do anything else. And that should be pulling up Discovery pretty soon. So let's just go ahead and jump ahead. Okay, this now says ready, which means that Discovery should be open, and that will be this little icon right down here with the impossible triangle. Currently, this is the geometry we have because this is what I selected before. This was the nosecone.xt. But this is not what we want to use, so let's right-click that and then go delete it, which is right down here at the bottom. Right-click again, delete. You should have a completely blank slate when you open up discovery. There. Now everything should be completely empty. So let's go create a sketch on this plane. I'm not going to teach you how discovery works, but I will just give you, I'll just lead you through the steps. If you click right here, then that should orient your view like this. I'm going to go to sketch, and we're going to, first let's make sure our units are in millimeters. Yep, metric millimeters, that's correct. We are going to make a rectangle, so select rectangle up here. And if you want to zoom in and out, that's scroll. If you want to rotate the view, that's middle mouse button. And if you want to pan, that's hold control and then click and move middle mouse button. That's worth knowing. It's going to be the same for a lot of CAD software and as well as for using Ansys Mechanical. So just remember that. Middle mouse button to rotate, control plus middle mouse button to pan. Again, click Z right here. We're going to use this rectangle sketch tool. Click once, drag this over till it's 10 millimeters, and drag this up, and then left click again. We're going to do this 3 more times, creating 3 10 millimeter by 10 millimeter squares, which we're going to use in Ansys Mechanical. The basic premise of CAD software, if you don't already know, is that you make a two-dimensional sketch and then you take that and you rotate it or you pull it, and that creates a 3D object out of a 2D sketch. So that's what we're going to be doing here. We're going to move from sketch to pull, and that is going to let us take these 2D shapes and then pull them up. Now, if you pull this, you can see it's got a dialog box where we can edit the text. So with your mouse still on the left mouse button, type 10 in and press enter. And now if your finger's still on the left mouse button, it's not going to do anything. You can take that finger off. So we're going to do this again, but if we just click and drag, you can see this is going to be merged into one body. We want 4 separate cubes. So hold Control and press Z to undo. We're going to click No Merge. That's going to make sure Discovery does not merge these two. And click and drag, type 10 and press enter again. And click and drag again. 10, enter, click and drag, 10 and enter. That is our 4 10 millimeter cubes. And that's what we're going to be using for our tutorial for Ansys Mechanical, which we'll get to in a minute. So you don't need to save this. You don't need to click anything. You can just go X, and that will close that. And now geometry has a little check mark because geometry is done. So there are 4 more things to go through in Workbench: model, setup, solution, and results. But if you double left click any of these, then that is going to take you to Ansys Mechanical. It's going to open it. It's going to turn this red and say opening mechanical. And we don't want to do that yet. That's for the next video. They're all closely related and they're all going to be edited from mechanical, and we'll get on to the rest of these in the next video. Before we move on to mechanical, I'm going to show you that if you click X up here, this is going to say the current project has been modified. Do you want to save it? You can click yes, and that'll do the same thing as if you clicked the save icon up here. And then it will close Ansys Workbench, and you're good to go. But you should just leave yours open because we're going to be coming back to this in the next video. All right, that completes this tutorial of Ansys Workbench. So as always, may the Lord bless your engineering. Come visit us at LU sometime, and feel free to start the next video, which will be on Ansys Mechanical.